Okay. I'll try my best to explain this. I hope this makes sense. The first thing I do before I start anything is SST and SCT. And then so in this case, I believe my SST was like 52, 53, let's just say 52. SST is 52 and our SCT is 100. So the very first thing I do is I plot my SST line. Now, in case you don't know, this thumb is your saturation thumb. So anything that's inside of this thumb is saturated. If it goes to the right of the thumb, it's superheated or 100% vapor. If it goes to the left of the thumb, it's subcooled or 100% liquid. So if your line hits this, that's superheat. If your line hits over here, that's subcooled. Now, SST 52. So here I got to 40, I went halfway and a little bit above, and then I drew a straight line a couple inches outside of saturation on each side. Just draw a straight line. Your SCT 100. Go up to your 100 line. Again, draw a straight line, couple inches outside of saturation on each end. This bottom line represents your evaporator. This top line represents your condenser. The next thing we're going to do is our superheat. So how far of our evaporator line are we going to go to? 52 plus 20 is 72. Right here to the right of your thumb are temperatures. We need to find 72. So there's 60 and there's 80. So we'll say midpoint is 72. We're going to, let's say, follow this 80 until it intersects with our evaporator. And we're going to go a little over because it's in the middle of 60 and 80. So right there. And then we're going to dot that. Our subcool is 100, subcooled 20. So it's 100 minus 20, which would be 80. 100 minus 20 is 80. We're going to follow this until it hits the edge of saturation, right? Because everything beyond this point is subcooled. So we follow it. As soon as we start our subcool, you can dot that too. You can dot that and then just draw a line straight up so it intersects with your condensing line. So your condenser line is going to go, and then from this point, it's subcooling up until this point. And then once you have that, dot it, and I recommend drawing a straight line down to complete your cycle, which is it goes the start of your evaporator to the end of your evaporator, which is the start of your compressor to the end of your compressor, the start of your condenser to the end of your condenser, and then the start of your metering device to the end of your metering device, heading back into your evaporator. Evaporator, compressor, condenser, metering device. Now, each dot you've made, boom, boom, and boom, draw a straight line up so you can get a BTU value. You need these to figure out your NRE, your net refrigeration effect, your HOR, your heat of rejection, and your HOC, which is heat of compression. So I'm going to do this. Hold on. Evap. Your NRE is your evaporator. Your HOR is your, I'll put cond for condenser. And your HOC is for your compressor. So when you're figuring out your NRE, you are going to use the start and end point of your evaporator line. So we have here, follow the line up. It's about 127 minus the start point, 43. 127 minus 43 gives us 84 BTUs per pound. I should write that down. BTU per pound. Our heat of rejection, we're going to use both points of our condensing line. So the furthest point of our condensing line is right here. It's where our condenser starts, which is 137, to the end of our condenser, which is 43. So 137 minus 43 gives us our HOR of 94 BTUs per pound. And then heat of compression. We go to our compression line, which is right here from this point to this point. We're going to take 137 minus 127, which will give us 10 BTUs per pound. So that's our NRE, HOR, and HOC. Now, he might ask questions like, how many BTUs did it take to superheat the refrigerant? Superheating takes place in your evaporator, so you know it's going to be on this evaporator line. Superheat takes place after saturation, so you know it's not superheating here because it's a latent exchange. So from the minute it leaves saturation to the point of... Wait, hold on. I'm stumbling. If it asks how many BTUs it took to superheat your refrigerant, it starts from this point, and you draw a line straight up. I feel like pointing this out. So like this point is, I put 123, and that point is a bit back. It kind of curves back. So maybe that's like 122. But for the sake of the video, let's just say we drew a straight line up and it's 123. 123, and here is 127. So it took 127 minus 123 took 4 BTUs to superheat our refrigerant. If it's asking desuperheating, that takes place in the condenser. The condenser starts here, and it desuperheats to this point, and once it becomes saturated, it's no longer superheated, so it's fully desuperheated. So if they asked you, how many BTUs did it take to desuperheat? You would go from the start of the condenser, 137 minus, right here, 123. So 137 minus 123 is 14. It took 14 BTUs per pound to desuperheat. Another thing is, okay, latent exchange. Okay, you have latent exchanges and sensible exchanges. A latent exchange is a change of state, not temperature. So everything inside this thumb is a latent exchange. So if he's asking how many BTUs did it take, how did he word that question? How many BTUs did it take, or how many BTUs were used during the latent exchange in the evaporator? So you go to your evaporator, you're going to use the start of your evaporator right here. And right there, which we'll say is 122, if we drew a straight line up. 122. So you would go 122 minus 43 is whatever the math is. That would, I feel like I'm mumbling now. 122 minus 43 is the amount of BTUs the amount of BTUs that were used per pound of during the latent exchange. If they were asking how many BTUs were used in the wait, why am I struggling to explain this? Okay. Latent exchange in your evaporator is from here to here. Latent exchange in your condenser is here to here. A sensible exchange in your condenser would be from here to this point, right? And from this to this, right? So you have a sensible exchange here and here. You have a sensible exchange in your evaporator right there. I think that's it. I think that's all you need to know. If they're asking how many BTUs were used in your metering device, it goes straight down. There is no BTU exchange. So as it goes from a subcooled liquid back into a saturated liquid vapor mix and it hits your evaporator, there is no BTU exchange. There's a temperature exchange, but no BTU. Or there's a change in temperature, there's a change in pressure, but there's no change in BTUs. This is 10 minutes already. I hope this helps. If you have a more specific question, let me know. But I feel like I kind of covered everything.